Hello and welcome to Jobs and Education. This is your Mahesh Dole. Do subscribe and share my videos. Hello and welcome to Jobs and Education. This is your Mahesh Dole. Do subscribe and share my videos. Today's topic is plumber block. Today we are going to learn about the production drawing of a plumber block. This is very important for diploma as well as BTech students of mechanical engineering. So very important, that is plumber block. It is also called as pillow block or pedestal block. It is used to support for a rotating shaft with the help of compatible bearings and various accessories. So what is it used for? It is used to support our rotating shafts. So its applications are heavy and medium conveyors, mining, aggregate and cement, industrial fans and blowers, stone crushing industries, lifts and cranes. These are the major important applications of a plumber block. So plumber block is used to support rotating shafts. These all are the industries are having some of the rotating shafts. To support those rotating shafts, we are using plumber block. So this is a question of plumber block in production drawing of diploma as well as BTech students. So this question is illustrating the assembly drawing of a plumber block. In this 3D figure we can understand how the parts are assembled together. See, the question is that he is asking, draw the component drawings, apply suitable geometric tolerances and fits, and show the surface roughness symbols, and draw the process sheet. These are the 4 important questions for this production drawing of a plumber block. So in this figure we can understand different number of parts. How many parts are there? Base, bearing brass, again bearing brass, cap, bolts with nuts. So where is the base? This first component, whatever the first component showing here, that is a base. So what is bearing brass? Second and third, 2 parts are bearing brasses only. This second and this third, means this rings, inside rings are called as bearing brasses. And fourth one is cap. This cap is nothing but this is the fourth part. So this portion we can call it as cap. And fifth one is bolts with nuts. So these are bolts with nuts. So these are the 5 important parts we can see here. So in the question, the front view and top view given and parts table given, and asked 4 different type of questions. Look at this, the top figure which is rotating, that is a total assembled figure of plumber block. These all are individual parts. So this part is nothing but base. So base we seen as a major part. We can call it as body also, base and body. So this is a major important part, first part. These 2 rings, semicircular rings, are nothing but bearing brasses. So these 2 bearing brasses are very important. These 2 are joined together to create a hole like a structure. In that one we can keep the rotating shafts, because of this plumber block is used to support the rotating shaft. This is the 4th part, that is nothing but cap, which we can keep at the top of the base after keeping bearing brasses. And these are the bolts we can insert from the bottom of the base. After inserting this, we need to keep the washers and nuts and lock nuts. So this is the way of assembling our total plumber block. So how many parts are there? After bringing all the individual parts alone, so we need to form this kind of things. We need to form component drawings, we need to prepare geometrical tolerances and fits, surface roughness symbols and process sheet. So these are the things we need to prepare after drawing component drawings or after drawing individual parts. In the question we seen 5 parts: base, bearing brasses, cap and bolts with nuts. So this first part is the base, so its top view is this. So this complete portion is first part only. And second and third are bearing braces. Bearing brasses means this is the front view, this is the top view of bearing brass, second and third part. And fourth is cap. This is the cap, its top view is this. So this is completely 4th part, it is a cap. And 5th one is bolts with nut. This is the 5th part, that is bolts with nuts. So drawing this component figures means individual parts alone. So after enlarging or after drawing this individual parts, we need to indicate the surface roughness values and also surface roughness symbols, tolerance symbols, and we need to prepare process sheet, and we need to prepare type of fit table also. These are very important. The process sheet, it is prepared for bearing brass. So the skeleton of the process sheet is very important. First of all, we need to draw the table. In that one, above the table you need to write part number, description. Description is also called as part name, material, time, quantity and size. In the table the columns are serial number, machine required, operation required, tools required and time taking. So these all are the columns are very important to prepare the process sheet. And the process sheet we are preparing for bearing brass, that is nothing but these two rings or these two semicircular objects. These two are bearing brasses. So for preparing process sheet, so let's look at the process sheet. First of all, checking the casting or checking the component sizes are very important. So whatever this bearing brass is there, for that checking the component size and checking the casting. So after that checking is with the help of vernier calipers. So after that, fix the job in the chucks. Fixing this job in the chuck of the lathe machine. So what is the machine required here? The machine is lathe machine. What is the operation? Fixing the job in the chuck. So any tool required here? No need to use any tool. Second operation is facing the end. So face this end, facing the end with the help of, again in the lathe machine only, with the help of facing tool. Next operation is turning of 76. Next operation is turning of 76 into 10, that is this is 76 and the height is 10. So 76 into 10. Next operation is turning of 76 diameter into 10, that is this 76 into this 10 height. So that is in lathe machine only with the help of a turning tool. After that, turning of 64 diameter into 12. Where is 64? This is 64 diameter. From here to here it is 64 and the height is 12 mm. So 64 into 12, that is with the turning tool, again on lathe machine only. Next operation, turning of 60 into 40. Again this diameter is 60 and this length, look at this, from here to here is 12 plus 12 plus 12, 12, 24 and this gap is 16, total 40. So 60 into 40 turning operation with the turning tool on lathe machine only. So reverse the job. After completing from one side, reversing the job in the lathe machine. So again turning of 64 into 12. So other side also 64 into 12 is there, turning of that side with the turning tool. Next turning of 76 into 10. So that side also 76 is there, from here to here it is 76 and the height is 10. So same thing, that side also 76 into 10 is there. So do the turning operation with turning tool on lathe machine. So after completing this turning and facing operations, so fix the job in the drill jig. So after fixing the job in drill jig, drilling a hole of 3 diameter. This is the hole 3 diameter. So fixing the job in the drill jig and drill the hole of 3 diameter with the drill bit. So this is the way of preparing a process sheet. So what is important here? We need to understand the skeleton and what are the operations required, what are the machines required and what are the tools required and what is the time. So operations, we understood that mostly turning and facing operations we are doing on the lathe machine only. So with facing tool, turning tool. So when we fix a job in the drill jig, we'll use a drill bit to prepare a drill hole. So finally we need to inspect the object, that is bearing brass. So this is a way of preparing process sheet. Next is preparing mating parts or fits table. Here how many mating parts are there? We can see most important are two. One is base and bearing brass. Base is the first one and bearing brass are second and third. Base means this complete frame, base is this frame. So that is mating with the bearing brass. So this inside ring is called as bearing brass. These two are mating here. Its fit is medium fit. Next is base and cap. So again this base is mating with this cap. This above portion is nothing but cap. Fourth part is cap. That cap is mating with the base. So that type of fit is nothing but press fit. So these are the two important pairs mating together. This is very, so as we seen component drawings, first individual drawings, next we seen type of fit table and we seen a process sheet. So again we need to prepare geometric tolerances and surface roughness symbols like straightness, flatness, circularity, cylindricity, parallelism, perpendicularity, angularity, position, symmetry, run out. So these kind of tolerance symbols we have. So how these symbols we are using in the answer? Look at this. Here this is a perpendicularity symbol, this is the cylindricity symbol or cylindrical symbol, this is a concentric circles or concentricity symbol, this is run out symbol. So how these symbols are using here? This symbol is nothing but perpendicularity, means the surface two lines are making perpendicularity of 90 degrees. This run out is nothing but it is the circular object which are maintaining axis, so that is nothing but run out, we can say it as. So this coaxiality or concentricity means whatever the different diameters are there, those different diameters are following only one axis, that is nothing but we can say it as concentricity. That's why circle in another circle. This is cylindricity. Cylindricity means cylindrical object. So if the cylindrical object is there, we can indicate with the cylindricity symbol. So that's why these bearing brushes, when they join together, it looks like a cylinder. That's why we can use this cylindricity symbol. So in this plumber work, we can use this perpendicular symbol and this cylindricity symbol, run out symbol, and this concentricity symbol. So 4 symbols we can use from these tolerance symbols. Next is surface roughness symbols. These are the surface roughness symbols, very important. This third one is very important. Wherever the machining is required, if the removal of material by machining is required, there we use this symbol and we indicate the surface roughness numbers on this above figure. Look at this. Here we seen this is a symbol of machining, the number taken as 3.2. Here it is the symbol of machining and 12.5 is there. So what is 12.5, what is 3.2? Look at this, when you see this 12.5, this is belongs to drilling. So mostly 3.2 is nothing but 3.2 is having with these 3. So this is reaming, broaching, hobbing. So 12.5 is nothing but drilling. This 12.5 indicated for the holes. This 3.2 indicated for the reaming or broaching. So this kind of values and symbols we can use from the surface roughness symbols and surface roughness values. So this is a way of indicating surface roughness symbols, surface roughness values, tolerance symbols, and preparing process sheet and also preparing type of fit table. This is what total about the component drawing. Finally, we can call it as the production drawing of the plumber block. So all the best for your coming up exams and also competitive exams of mechanical engineering. So do subscribe and like and share the videos of jobs and education. So this is your Mahesh Dole. Thank you very much. Signing off.